Look up at the night sky and you'll see a vast expanse dotted with stars. Each of those tiny points of light represents a distant sun, a beacon of light in the darkness of space. But the night sky holds more than just stars. It is a canvas painted with the history of our universe, a history that includes countless cosmic events and phenomena. Among these twinkling points of light are celestial wanderers, meteors. These meteors, often referred to as shooting stars, are not stars at all. They are fragments of comets or asteroids that have broken off and are traveling through space. When they enter Earth's atmosphere, they burn up, creating a bright streak of light across the sky. These cosmic visitors have been colliding with Earth for billions of years, shaping our planet's history in profound ways. Each impact, whether large or small, has left its mark on the Earth, contributing to the ever-changing landscape we see today. The story of these impacts is a story of destruction and creation, of endings and new beginnings. From the very beginning, Earth has been bombarded by these space rocks, some small and insignificant, others large enough to cause widespread devastation. The early Earth was a chaotic place, with frequent impacts that played a crucial role in shaping the planet's surface and atmosphere. These impacts brought with them not only destruction but also the building blocks of life. The evidence of these ancient collisions is etched into Earth's surface. Craters, some spanning miles across, serve as stark reminders of the immense power these celestial objects possess. These craters are more than just scars on the Earth's surface. They are windows into the past, telling the story of our planet's violent history. Craters, some spanning miles across, serve as stark reminders of the immense power these celestial objects possess. These craters are not just geological features, they are monuments to the forces that have shaped our world. Each crater tells a story of a moment in time when the Earth was forever changed by a cosmic event. These impacts have not only sculpted our planet's physical features, but have also played a crucial role in the evolution of life itself. The energy released by these impacts has the power to alter climates, trigger volcanic activity, and even influence the course of evolution. Some scientists believe that the building blocks of life may have been delivered to Earth by comets and asteroids, making these impacts a key factor in the origin of life. The threat of meteor impacts is not a relic of the past, it remains a present danger. While the chances of a catastrophic impact are low, the potential consequences are so severe that it is a risk we cannot ignore. Modern technology allows us to track and study these celestial objects, giving us the tools we need to protect our planet. While catastrophic collisions are rare, they are a stark reminder of our planet's vulnerability in the vastness of space. The vastness of space is filled with countless objects, each with the potential to cross paths with Earth. Understanding these objects and their trajectories is crucial for our safety and survival. Understanding these celestial threats is crucial for safeguarding our future. Scientists and astronomers around the world are dedicated to studying meteors and other near-Earth objects. Their work helps us to better understand the risks we face and to develop strategies to mitigate those risks. By studying the past, we can better prepare for the future, ensuring that our planet remains a safe haven in the vastness of space. Meteors, often referred to as shooting stars, are not stars at all. They are chunks of rock and metal, remnants from the early solar system, that hurtle through space at incredible speeds. These space rocks come in a variety of sizes, ranging from tiny dust particles to massive boulders. The smallest of these objects, known as meteoroids, are no bigger than grains of sand. As they enter Earth's atmosphere, they burn up due to friction, creating a brief, brilliant streak of light. Larger meteoroids, called fireballs, create spectacular displays as they blaze across the sky. Sometimes even larger space rocks survive their fiery descent and crash into Earth's surface. These survivors are known as meteorites. They provide scientists with valuable insights into the composition of asteroids and the early solar system. The solar system is a dynamic and constantly moving environment. Planets orbit the sun, and countless asteroids and comets follow their own paths through space. Occasionally, these paths intersect with Earth's orbit, leading to the possibility of a collision. One of the main sources of meteoroids is the asteroid belt, a region between Mars and Jupiter where millions of rocky bodies reside. Gravitational interactions within the asteroid belt can nudge these objects out of their stable orbits, sending them hurtling towards the inner solar system. Comets, icy bodies from the outer solar system, also contribute to the meteoroid population. As comets approach the sun, they heat up, releasing gas and dust that form a distinctive tail. This debris can linger along the comet's orbit, creating a stream of meteoroids that Earth may encounter. Section 4. Scars on Earth. The Chicxulub impact and the dinosaur extinction. 66 million years ago, a cataclysmic event forever altered the course of life on Earth. This event was so powerful that it left an indelible mark on our planet, a scar that tells the story of one of the most dramatic episodes in Earth's history. An immense asteroid, estimated to be 6 miles wide, slammed into the Yucatan Peninsula in what is now Mexico. The force of the impact was so great that it created a crater over 110 miles in diameter and 12 miles deep. This impact, known as the Chicxulub event, triggered a chain reaction of catastrophic events. The initial explosion was just the beginning of a series of disasters that would unfold over the following days, months, and years. The impact released an unimaginable amount of energy, equivalent to billions of atomic bombs. The explosion sent shockwaves across the planet, causing earthquakes and volcanic eruptions. It ignited wildfires that raged across continents, burning everything in their path. These fires released massive amounts of carbon dioxide and other gases into the atmosphere, contributing to a dramatic shift in the planet's climate. The impact also generated colossal tsunamis that inundated coastlines, sweeping away everything in their path. These waves reached heights of hundreds of feet and traveled thousands of miles, reshaping the geography of the continents. Additionally, the impact released massive amounts of dust and debris into the atmosphere. This debris formed a thick cloud that blocked out the sunlight, creating a phenomenon known as an impact winter. This debris choked out the sunlight, plunging the planet into a prolonged period of darkness and cold. Temperatures plummeted and photosynthesis was severely disrupted, leading to a collapse of the food chain. The consequences for life on Earth were devastating. Ecosystems that had thrived for millions of years were suddenly thrown into chaos. Many species were unable to adapt to the rapid changes and perished. The Chicxulub impact wiped out an estimated 76% of all plant and animal species. This mass extinction event marked the end of the Cretaceous period and the beginning of the Paleogene period. Among the casualties were the dinosaurs that had ruled the planet for millions of years. These magnificent creatures, which had dominated the land, sea, and air, were suddenly gone, leaving behind only their fossils as a testament to their existence. This event, a stark reminder of the destructive power of meteors, serves as a sobering example of how fragile life on Earth can be. It highlights the importance of understanding and monitoring the threats posed by near-Earth objects. However, the Chicxulub impact also paved the way for the rise of mammals and the eventual emergence of humans. With the dinosaurs gone, mammals were able to diversify and occupy ecological niches that had previously been dominated by the giant reptiles. Over millions of years, these early mammals evolved and adapted, leading to the development of primates and eventually, humans. The Chicxulub impact, while devastating, set the stage for the evolution of our own species and the world we know today. Section 5. The Tunguska event, a devastating airburst. While large impacts like Chicxulub are relatively rare, smaller meteoroids can still pose a significant threat. These celestial objects, often no larger than a grain of sand, travel at incredible speeds and can cause significant damage upon entering Earth's atmosphere. The night sky, filled with shooting stars, is a beautiful reminder of these small but powerful visitors from space. In 1908, a massive explosion rocked the remote Tunguska region of Siberia. This event, shrouded in mystery and intrigue, has fascinated scientists and researchers for over a century. The explosion was so powerful that it was heard hundreds of miles away, and the shockwave was felt across continents. The event, known as the Tunguska event, flattened over 80 million trees over an area of 830 square miles, releasing energy estimated to be 1,000 times greater than the atomic bomb dropped on Hiroshima. The sheer scale of the destruction was unprecedented, leaving a scar on the landscape that can still be seen today. The cause of the Tunguska event is widely believed to be an airburst. This phenomenon occurs when a meteoroid or comet explodes in the atmosphere before reaching the ground. The explosion creates a powerful shockwave that can cause extensive damage over a wide area. As a meteoroid enters the Earth's atmosphere at high speed, it compresses and heats the air in front of it. This process generates intense heat and pressure, causing the meteoroid to glow brightly as it streaks across the sky. The sight of a fireball blazing through the atmosphere is both awe-inspiring and terrifying. This intense heat can cause the meteoroid to explode in the atmosphere before it reaches the ground. The explosion, known as an airburst, releases a tremendous amount of energy, creating a shockwave that can devastate the surrounding area. The bright flash and thunderous boom of an airburst are unmistakable signs of its destructive power. While airbursts may not leave behind a crater, they can still cause widespread damage. The shock wave from the explosion can flatten forests, shatter windows, and cause significant structural damage to buildings. The aftermath of an airburst is a stark reminder of the power of these celestial events. The blast wave from an airburst can flatten forests, shatter windows, and even injure or kill people. The Tunguska event, with its massive shock wave, caused widespread devastation and left a lasting impact on the region. The stories of those who witnessed the event are filled with awe and terror as they describe the sky lighting up and the ground shaking beneath their feet. The Tunguska event serves as a chilling reminder that even relatively small meteoroids can have a devastating impact. The event has prompted scientists to study the potential threats posed by near-Earth objects and to develop strategies for detecting and mitigating these dangers. As we continue to explore the mysteries of our universe, the Tunguska event remains a powerful example of the forces at play in our cosmic neighborhood.